Hello, geometry students. Today we finally get into triangle proofs, and this is what we've kind of been building up towards. So to be able to prove triangles congruent, there's a bunch of ways that there are basically shortcuts so that you don't have to prove every segment and every angle congruent. If you can prove just enough, that'll do it. So the first method that we're going to talk about is called side, 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 but we abbreviate it to SSS. But that's what it actually stands for, is side, side, side. And what that means is if we can prove that all three sides of one triangle are congruent to all three sides of the other triangle, or the corresponding sides, that's enough to prove the triangle's congruent. Now, we're going to have to pretend a little bit here. So what I want you to pretend right now is that all these things are actually being given to you. And they are, because I'm giving them to you. But pretend that they were part of a set of givens. So I would tell you that AB is congruent to DE, and that would be one pair of sides. And then the second thing I would give you is that BC is congruent to EF, and that would be a second pair of sides between the triangles. And then you'd have the last pair, AC congruent to DF, and that would be your third pair of sides. So on a longer proof, there might be some other steps in here as well, but ultimately you need to get each pair of the sides congruent. Then you'd be able to say that triangle ABC would be congruent to triangle DEF. And the reasoning would be that side, side, side of one triangle is congruent to side, side, side of the other. And that's what the proof will look like. There's also a second method that we're going to cover today, and that one is called side angle side. So it looks a little bit like SAS, but it really reads as side angle side. All right, and it is exactly how it sounds. It's going to be two sides of one triangle congruent to two sides of the other. And then what we're going to call the included angle has to be congruent from the one triangle to the other. So as an example, again, you're going to pretend that all of these things are just being given to us. So I'm going to say that side GH is congruent to side JK. There's one pair of sides. And then I'm going to tell you that side HI is congruent to side KL. All right, there would be my two pairs of sides. The included angle, because it reads as SAS, the angle has to fall in between the two sides. So if I were to trace the two sides out, you're literally tracing the angle right there. It would have to be angle H. So it'd be angle H congruent to, and now trace the two sides here. The included angle would be angle K. So I'm just going to write a little note. That's called the included angle, which is code for the angle between the sides. And if we're given those, that would be enough to then say that triangle GHI is congruent to triangle JKL. And our reasoning would be side angle side of one triangle is congruent to side angle side of the other. Now, a couple of things. The order in which you say this over here in the proof doesn't actually matter. What matters is the order that it shows up in the diagram. So if it's side angle side here in the figure, that's what actually matters. Okay, a couple of things. Keep in mind, use the given as a checklist, so make sure everything makes it in there. If you don't end up using a given, that's not usually a good sign. If it's given to you, you want to be able to use it. And then there's only two things that we're allowed to say without the given being handed to us. One is we're allowed to say that we have vertical angles, implying that there are congruent angles. And so that's when you have like the X shape, the top and bottom, right? Or side and side, however it looks. And then the other piece is the reflexive property. And we use that when we have overlapping or possibly shared, you might think of it that way, parts. And we're going to see some diagrams where that'll make sense. Right? And then lastly, make sure to mark the picture as you go, because you're going to want to see in the diagram, do I have side, 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 or do I have side, angle, side? So that visual piece is going to be super important. All right. let's get going. Let's try this out. So this first one here, you've got a couple of givens, and what we're going to try to prove is that triangle ABC here is congruent to triangle EDC. So that is our end game. So under our statements, let's get started with the very first given. So EC is congruent to AC. Given. Make sure, next thing, mark that in the picture. So EC, right here, congruent to AC. Those are a pair of sides in the triangles. So right next to it, I'm going to put S so that I remember that we've got one pair of sides congruent right now. All right. Since there was no vocab term and nothing that I could conclude from this, I'm going to go right on to that second given here. So my second given, I'm going to squeeze in step one. It's C is the midpoint of segment DB. All right, and still given. Now we've got a vocab term to work with. So my midpoint means that I can carry that vocab term right here. From our reason sheet, we know that midpoint implies two congruent segments. So I have to state which two segments those are. So into the diagram, if C is the midpoint of segment DB, so this whole segment here, then it's breaking it up into the two congruent segments, DC and CB. So DC and CB. And that gives me a second pair of sides right there. All right. When you look, we are out of givens. So that means we're going to default to what can we say without a given. So when you come back to that last page, and you can flip back if you need to, vertical angles, or do we have something overlapping? So in this case, we've got that nice X shape right in between the two figures. And so we have a pair of vertical angles right here. So step 3, I'm going to state that vertical angles implies that we have two congruent angles. Now, how you name the angles? We can call them angle DCE and angle BCA, or what I'll often do is I'll put numbers in the angle and refer to it as angle 1 and angle 2. It just makes things a little bit easier in terms of being able to spot where the angle is. The only thing you can't do, you cannot call that angle C. There's way too many angles at that point to know which angle you're talking about. All right, there's a pair of congruent angles. And now look at the order. We have a side here, an angle, and a side here. So if the angle is connecting in between those two sides, that is code for we've got side, angle, side. And we're allowed to say that triangle ABC is congruent to triangle EDC. And now over here, you can say side, angle, side congruent to side, angle, side, but we tend to shorten that up and just list it that one time, right? So you can show it either way. All right. If you find that you struggle at all trying to figure out what is the reason at the end, cover up so that you only see one triangle. And when you're focusing on one triangle, then you can see that, yep, I've got two sides and the included angle. That's how I know it's SAS. Let's take a look at that next one here. Same as last time. You know how to start these. You're always starting with the given. So we have FG is congruent to HI. Go ahead and mark it. Here's FG, here's HI. And because we are trying to prove these triangles, the triangle at the top congruent to the triangle at the bottom, that is immediately a pair of sides right there that are given to us. There's no vocab term, so I'm going to go ahead and put that next given right in there. So FI is congruent to HG. So FI, I'm going to put a little double stripe, and HG, another double stripe. So that's another side in those triangles that we know are now congruent. But now I'm out of givens. So I have to think. All right, come back to that little reminder. I'm either looking for vertical angles or the reflexive property. So vertical angles, well, I don't have the X shape this time. But if I look at the triangles, they share a part. So when you trace out triangle FGI and triangle HIG, they share that side right down the middle. That segment is part of both triangles. And so I put a little X over it to show that it's congruent to itself. If I state that, that gets me a third pair of sides. So we can say that IG is congruent to IG, or you can say GI, either way. And that's our reflexive property. All right, that gives us the third pair of sides. So if I cover up one triangle, I can see right here, side, 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 and there we go. All right, something that you have to make sure of. You can't say, well, angle F looks the same as angle H. Nope, I almost need you to play a little stupid on these ones, that if it doesn't say it and we don't know definitively that they're congruent, you can't assume anything, right? So based on our givens and based on the reflexive property, we can say that we have all three pairs of sides congruent. So we can say triangle FGI is congruent to triangle HIG. And then my reason over here is side, side, side of one triangle is congruent to side, side, side of the other. So feel free to leave it with just SSS, or you can show both parts of that. All right. I think that we might want to save one, at least for the start of class tomorrow. Yeah, why don't we stop here? And we're going to save 3 and 4, both of these, for our recap for class. So you got those first 2 pages done. We'll save that last page as almost like a little warm-up the next time we see each other. Thanks, guys. Go answer that post-video question now.